Enterotoxin, Wikipedia audio. An enterotoxin is a protein exotoxin released by a microorganism that targets the intestines. Enterotoxins are chromosomally encoded or plasmid-encoded exotoxins that are produced and secreted from several bacterial organisms. They are often heat-stable, and are of low molecular weight and water-soluble. Enterotoxins are frequently cytotoxic and kill cells by altering the apical membrane permeability of the mucosal cells of the intestinal wall. They are mostly pore-forming toxins, secreted by bacteria, that assemble to form pores in cell membranes. This causes the cells to die. Enterotoxins have a particularly marked effect upon the gastrointestinal tract, causing vomiting, diarrhea, and abdominal pain. The action of enterotoxins leads to increased chloride ion permeability of the apical membrane of intestinal mucosal cells. These membrane pores are activated either by increased CAMP or by increased calcium ion concentration intracellularly. The pore formation has a direct effect on the osmolarity of the luminal contents of the intestines. Increased chloride permeability leads to leakage into the lumen followed by sodium and water movement. This leads to a secretory diarrhea within a few hours of ingesting enterotoxin. Several microbial organisms contain the necessary enterotoxin to create such an effect, such as Staphylococcus aureus and E. coli. Clinical significance. Staphylococcal enterotoxins and streptococcal pyrogenic exotoxins constitute a family of biologically and structurally related toxins produced by Staphylococcus aureus and Streptococcus pyogenes. These toxins share the ability to bind to the major histocompatibility complex proteins of their hosts. A more distant relative of the family is the S. aureus toxic shock syndrome toxin, which shares only a low level of sequence similarity with this group. All of these toxins share a similar two-domain fold with a long alpha helix in the middle of the molecule, a characteristic beta barrel known as the oligosaccharide/oligonucleotide fold at the N-terminal domain and a beta grasp motif at the C-terminal domain. Examples include enterotoxin type B. Each superantigen possesses slightly different binding mode when it interacts with MHC class II molecules or the T-cell receptor. Clostridium difficile, Clostridium perfringens, Vibrio cholerae, Staphylococcus aureus, Yersinia enterocolytica, Shigella dysenteriae. The beta-grasp domain has some structural similarities to the beta-grasp motif present in immunoglobulin binding domains, ubiquitin, 2-FE2S ferredoxin and translation initiation factor 3 as identified by the SCOP database. This article incorporates text from the public domain PFAM and Interpro IPR 006123. Classification and 3D structures. Bacterial, viral,